Again, the microphone is live. Broadcast is live. My handsome mug is on the face or on the screen, but we'll fix that. Make that go away. Hello, hello, hello. And we see that the little green lights show up when I speak at the bottom. Hello, 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 hello. Is it just you're broken? Oh, there we go. The microphone is live. No, broadcast. Sweet. Awesome. All right. Well, glad you guys were able to make it out. Today we're going to talk about more pandas. We looked at an overview last time of pandas from two perspectives. We looked at series, which were essentially columns, and we looked at data frames, which were essentially tables of data. Today's conversation, we're going to focus on how do you get your data out of some other source and into a data frame or into a series. We're going to focus predominantly on data frames. We're going to look at three methods. We're going to talk about how to get it from your clipboard if you've copied and pasted some sort of tabular data. We're going to look at CSVs, and we're going to look at SQL databases. One cool thing is a lot of what we learned tonight is going to apply to other sources of data. So this actually kind of can help you in multiple ways besides just those three data formats. All right. Let's see. N equals D. There we go. All right. Normally, when I start out with pandas, it is customary to import pandas using the alias PD. Just makes it easier to type. And then from pandas itself, typically folks will import series and data frame. I do that habitually. Today, I think we're predominantly going to use data frames. So importing series may not have been necessary at this point. But this is fairly common. You'll see this in most pandas programs right near the beginning. Pandas is adept at reading a wide variety of formats of data. In order to read in data, you typically use a pd.read command. And if you want to know the types of data that you can read in, you can type, for example, pd.read and then hit the tab key. And I'm going to do that now on the screen. pd.read. And if I hit tab, it'll show me there's 16 ways that you can read in data. From the clipboard, from CSVs, from Excel. And I'm going to caveat that. It does certain things with Excel. For those who don't know, FWF stands for fixed width fields. So if all the fields of your data are a particular width, you can use that. JSON, pickle format, stata tables, SAS. You can get your data from a variety of places. We're going to start by reading from the clipboard. So what I'm going to do is I'm going to open up a page in my browser and try and grab a good page. And let me find it. Dropbox, PyHawaii, talks. I've got a simple table on a HTML page. There we go. You can see it's nothing fancy. It's got columns of data. Each column has a header. Each row has got data in it. For convenience sake, all the cells that were in column 1 have a 1 in them. All the cells that were in column 3 have a 4 in them, just so we can kind of see that later when we look at the results. I'm just going to do a standard cut and paste. I highlight it. I'm going to do Control-C. It's now in my clipboard. I come back to pandas, and when I run the command on the screen, web data equals pd.read from the clipboard, it'll read in whatever's on the clipboard. If it finds it is tabular in some way, it'll try and decipher it as best it can. And I asked it to display what web data came out as, and you see it shows all 4 rows of the data. It shows the headers. Everything lines up the way it should. When pandas makes a data frame, by default, it gives you those index numbers at the beginning of every row. By default, it chooses to start at row 0, but you can alter that and tweak that a bit. All right. So let's look real quick at that board. I use the question mark in IPython to look at a particular function, I can get some help on it. In essence here, basically what it says is it'll try and read the text from the clipboard and it'll pass it to a function called read table. If you want to know everything that read table can do, you can go look at the read table help. And it does say that if it's unspecified, it will use the regex version of /s for any type of typical white space as the separators. So if you have tabular data that is separated by tabs, regular spaces, new line characters, etc., it'll assume that those are your separators. So if we want to see what we can do with read table, we can go there. And you'll see, if I scroll up again, the read table function has about 40 different arguments that you can feed into it. We are not going to go through all of these. We're going to see a number of them in the CSV conversation. But there are things like if you want to skip some initial spaces in a field, you can do that. If a particular character is going to be used as an escape character, you can do that. If a particular column is supposed to be dates and you want it to parse it as though it were dates, you can tell it to do so. If the file that you're reading in or the data you're reading in has some encoding like UTF-8 or something like that, you can tell it what encoding to look for, etc. So there's a wide variety of things that you can do. And because this is encapsulated in read table, it's also encapsulated in the clipboard function. So if you know your clipboard data has a column that is dates, or it has certain rows that you want to have skipped, etc., you can tell it to do that. And we'll see how to do a few of those things when we look at CSVs. All right. So with that, we've read in one piece of data from a clipboard. We're going to move on and start to dive into CSVs. We're going to get hot and heavy into a lot of the arguments that you can feed to it and the things you can do. I have a data file, and I will open it up and show it to you real quick. Log file CSV. I apologize, the font is really small. I'll walk you through kind of the essence of what you see here. Maybe I do one. All right. It starts off with someone's name. In this case, the first line has Barry Allen. It has their email address, ballen@justiceleague.org. It has an IP address where maybe their email communication or something came from, and an IP address of where their email communication went to. It's got a timestamp for when this happened, has some latitude and longitude numbers for where we believe maybe the email originated from. And then the very last item, in this case, like this 32171, it's the size of the payload for whatever message was sent on that day. We're going to use data that looks a lot like this throughout today's conversation. There's going to be some nuances, but most of them will fall in this category. Name, email address, from IP to IP, latitude, longitude, timestamp, and a payload. So let's read this in. And we see that Pandas spits out some sort of a result. A couple things to notice. The indexes started at 0. Maybe we want that, maybe we don't. The column headers, though, are probably not what we want. Column 1 is the Barry Allen column. And column 2 is the ballen@justiceleague.org column. For those who weren't here last time, when we look at the outputs from Pandas, anytime a table stretches across and is too wide for the screen, there's a continuation character at the top. It's a \. That just tells you this row is too long to display on a single line. And notice we appear to have 9 records. Starts at 0, goes to 8. But because we mistakenly read in the first row as a column header, we're missing one of our lines of data. So let's see if we can fix that. Notice I'm using pd.readcsv, and I throw in this little blurb here. I tell it, I'm going to use the following names from all of my columns. You put the names in the order of the columns. So my first column will be named name, my second will be email, etc. And the last one will be payload. I chose to write these kind of on 2 separate lines to kind of keep things clean. I'm going to give it a new name. My new data frame is going to be called named columns or named calls. And we run it. So let's ask pandas to show me what named calls looks like. And now we see that Barry Allen is no longer my column header. He actually has a header of name. The indexes still start at 0. They go to 9 this time, so I actually have 10 rows of data. Now, if you don't want to print out all the data to the screen, but you want to get a sense of what you got, you can use the info command and say, give me the information about the named calls data frame. And you'll see it'll tell me first off, yes, you are looking at a data frame. B, it's got X number of entries in the index. And it tells me that it starts at 0, goes to 9. Gives me the names of every column. Tells me the type of data that's in each column, whether it be an object like a string or it be an integer or a float. And it tells me how much memory is used by this data frame. If you're reading in massive amounts of data, sometimes you want to know how much space is this taking up. And we'll talk about a way to get around that in a little bit, if your data is too big to fit into memory cleanly. All right. So what if the data you get is not, say it's populated by some things that are corrupted or some things that you don't really want. So for example, let's just pretend that whatever product produced my data might put some metadata or something on certain lines. Maybe it has kind of a line that tells me where it came from and what version of the software produced the data, etc. You can actually tell pandas to skip those lines if you want. In the example that I have here, we're going to read the same data in, but I'm going to choose to skip lines 1, 2, 3, 7, and 9. So I'm going to get 5 rows. Remember, pandas starts counting at 0, so I'm actually going to get the quote-unquote first row. I'm going to have pandas show me just one column by running the .fmip command on the data frame. So if you want to look at an individual column, you can use this dot notation. It works really effectively. It's fast and easy to type. So let's go take a look at the from IP column and see what we get. Notice we only got 5 rows, which is what we expected. It starts counting at 0, but if we were to go back and look at some of the original data, so let me try and scroll up here. The original CSV that we read in from, row 0 starts with 246, and row 1 started with 253. And we see, it's 253 what? 253, 36. 207, 192. Okay. Notice this one starts with 246, but the next row does not end in 192. So it actually skipped some of the rows, and it skipped the ones that I wanted. Gave me row 0, and it skipped the original row 1. All right. Any questions? What if I have data and it's not separated by commas? The CSV specification is pretty loosey-goosey. People can put whatever you want in there as the separators. Say your data, for whatever reason, is separated by pipes. Pandas handles that with grace. You just tell it what separator you're going to use. In this case, I tell it my separator should be a pipe. I'm going to read in a brand new data file. It's called log file pipes. And all these will be up on GitHub, so you can play with them, hopefully later tonight. But the pipes data file has got pipe separators. Instead of commas, I've got a whole slew of these little vertical lines. And if all goes well, it should read that with no problem. And I'll ask it, what is pipes data? And it spits it all out, separated everything we wanted, gave it all the column names. Sometimes your data set's going to be huge. So looking at your entire data set is cumbersome. You don't want to display all of it on the screen. I've only got 10 lines, but if I had 10,000 lines. So just as a reminder from last week, you can use the .tail command on a data frame and tell it how many rows you want to see. In this case, I'm going to ask it to show me 3 rows, and it just spits out kind of this subsection. And the tail means it's going to look at the last rows of your data set. If I want to look at the first few rows, say I want to look at the first 4, you can use the head command. And you get 4. Okay. CSV files only use escape characters if the escape character is needed. And by escape character, for those in the audience who don't know, you might have, just as a sample, a string of text in one of your fields. And the string of text might be a sentence that somebody says, or it might be some sort of information. And what you might do is you might have some special character that the program should read, like a \T is supposed to represent a tab character, but maybe you actually want it to be a \, and you want it to be followed by a T. So you can put an escape character in to tell your program to ignore that \T and interpret it as what you really wanted it to be. When we finish this little slide here, we'll go back and look at all the things you can do with CSV read, and we'll see how you can include escape characters that you choose to include. All right. All right. Sometimes, especially if you're going to do graphing of like data that's time dependent, you might want to choose one of your columns to be the index instead of having those pesky 1s and 0s. And so in this case, you can tell it which column of your data should be the index. In this case, I said, you know what? This is date time data. Maybe I want to graph the traffic that's happening. So I'm going to choose the date time column to be my index column. I'm going to run this, and we say, show me what date index looks like. You see that all my indexes have been replaced. No longer goes from 0 to 9. The date time column is no longer in my table. The date time column is off on the far left side, and it is actually an index column. It is no longer considered raw data. There are ways to get it to leave your date time column as data as well, so you can use it as an index and as data, but I'll leave that as an exercise for the student. So let's go back and look a little bit more at the CSV thing. CSV, question mark. The question that was here in the room was, you know, how do we include escape characters? So when you create your CSV command and you're asking to read in CSV, if you have a particular escape character you want to use, you just tell it what it's going to be. By default, it's none. If your text, for example, is encapsulated by quotes to separate out like spurious commas or something like that, you can tell it what style of quote character to use, etc. Does that help? Sweet. All right. If you have an index, and a few minutes ago we used the command to create a date time index, you can actually index or grab rows based on that index. In this case, I'm using my data frame that I called date index, and I'm asking it to use the .ix method, and I'm telling it I want to see just the rows where the date time started from 2016 ending with 44 minutes and 56 seconds, going all the way up to the rows that include 49 minutes and 36 seconds. And when I run this and say, give me those results, we see that only 6 rows show up now instead of 10. And it starts at the one that started with or ended with 56, and it goes up to the one that ends with 36. All right. We'll see later on how you can grab just certain columns. But pandas are really flexible. You can grab the rows you want. You can grab the columns you want. And we're going to see how you can actually tell it to only read in certain columns. Instead of reading all the data, you just want to read in certain columns or certain rows. You can tell it to do that as well. So that way you don't fill up your memory. In this case, I'm using a brand new log file. It's called log file NA. Let me show you what that looks like. There we go. Let me try and get this blown up. Make this easier to see. There we go. So a couple things to note. In about the first 15 or 16 rows of this, I have created some places where there's going to be some null values of various types. So on row 1, I've got 2 commas that are side by side. When pandas tries to read this CSV, it's going to see the 2 commas, and it's going to put basically a null field, a field that has no content in it, into the table. And I can tell it how to handle that, make a decision as to what I want that to mean. And we'll see how that works. I've included some data that includes a capital N, a lowercase a, and a capital N. That's one of Pandas' key methods of identifying data that's non-existent or something that's not available. I've included NA in all capitals, which is, I think, another way that Pandas looks at this. For kicks, I included a number 9999 to show you how you can set your own signals for null values. Like, for example, if you have a date field, you might set a null value of any date from the year, the year 1 or the year 9,999. So you can set your own null signals. I've got a couple other places like in line 16 and 17 where we got some empty fields. And we'll see various ways how Pandas treats that or doesn't treat it, depending on what we ask it to do. So in this case, I'm going to read it in. I'm asking that it does absolutely nothing with the data. Just read it in and take it as is. So if I go look at the data, this file's longer than the others. It's actually 1,000 lines of data. And we see that in the latitude and longitude columns and the payload columns, a bunch of nada numbers have shown up. My 999 is in there. But all the places where I had an empty field, Pandas by default threw in an NaN marker. It will do that. You don't have to ask it to. If you don't want it to do that, we can turn that functionality off, and we'll see that in a minute. So any missing data automatically gets flagged as not a number. Noticed my capital N, capital A got changed over to Pandas default signal, which is N lowercase a, capital N. So all my NAs got converted as well. All right. The process of looking for NA values and then trying to convert the value to some sort of a flag is a time-consuming process, especially if you have huge amounts of data. If you don't need that check to be done, for example, you are confident that none of your data is null, you can turn that off. And I do that by saying NA filter equals false. So I run that. And if we go and look, now we see that the blank spaces that I have not been converted to NaN. They just got incorporated as straight blank spaces. My NAs did not get converted either. They're left as NAs. So again, a good time saver if you're dealing with lots of data. If you have particular values that you want to be flagged as NA values, you can give those as a list. So you can tell it, all right, anytime you see a blank space, consider that to be an NA value. Anytime you see 9,999, make that one also NA. So we do that. Say what data NA looks like. And notice I no longer have 9,999. They're all gone. All my spaces are all become NaNs. Now here's a fun thing. What if you have this data and it's got a bunch of NAs in it, but you don't want that? Pandas comes with a drop NA function, and it'll kill all the rows that have NA values in them. My data that we just created is 1,000 rows. I run the drop NA, and you notice it has dropped 13 rows out of the total. So very fast and easy to clean up your data set and look at only the rows that you care about and get rid of null values. Now, the drop NA function gives you some parameters. They have how, threshold, subset, and in place. The how argument determines when and where it's going to drop data. If you tell it that the how should be any, it will look in a given row, and if any of the values in that row are NA, it will drop the entire row for you. If you tell it that all values of the row must be NA, then it'll wait until it sees that condition. If you have a threshold that you'd like, for example, maybe your rows are 10 items long and you've got 3 NA values in that row and 4 NA values in the next row. You could set a threshold, and it should be an integer, and you say, my threshold is 4. So your row that had 3 NA values will get kept, but your row that had 4 NA values will get dropped. So lots of flexibility for kind of filtering out null values. If you only care about a subset of columns, you're like, you know what? I only care if there's null values in my lat long columns. I don't care if null values show up in the payload, null values show up in the email address. I only want to concern myself with this subset of columns. You can give it a list of column names with the subset parameter. So you give it an array, something like a list, and it'll go, all right, I won't check any other columns besides the ones you tell me. If you tell it to do in place, the default is false, which means it will make a copy of your data frame. If you tell it in place should be true, it will delete your original data frame and replace it with a cleaner, smaller subset of data. So very good tools for cleaning up your data and making things nice and pretty. All right. So next, we're going to look at, we got the same NA values we had before. Use the empty sequence, the empty string, use a string that has 999 in it. But now I can tell it, do not use any of your default pandas NA values. Don't use NaN, don't use capital N, capital A, just use the 2 values that I gave you. And if I run that and ask it to take a look at the data, we'll see that it did not convert my capital N's, capital A's. The strings all got replaced the way I wanted, and the 999s got replaced the way I wanted. But it ignored all of its normal default behaviors in preference of my own. All right. If you only want to look at a particular number of rows, like, hey, you know what, I only want to see 15 rows out of the data set. Maybe you're trying to get a subset of your data, a real quick sample or something. You can tell it how many rows to assess when it reads in the data from your CSV. In this case, I'm going to tell it go for 15 rows. Hit that, and let's look at the data. And now you see it stops at only 15 rows. Doesn't go up to 9. Doesn't go up to 1,000 rows. So very convenient data handling. All right. I mentioned earlier that if you're reading in large sets of data, pandas is going to try and make this table in memory. And if you know that the data is too big to fit into memory, you can process it portion by portion using the chunk size argument. In this case, I'm going to tell it my chunk size should be 3, and that means 3 rows. I'm going to read in from my log file. This is the original file we looked at. It's only got 10 rows in it. And for sake of argument, I've created a very simple for loop, and I've put in some print statements to simulate doing something. So let's just pretend you've got a large data set and you need to do some sort of pre-processing in preparation for reading in your next batch of data. Then you need to do a little bit more pre-processing. You got some functions that are going to run. And eventually you need to read in your chunk of data, your 3 or 4 lines, and then you want to do some post-processing. Once you finish the post-processing, you want to cycle back through the for loop and you grab your next chunk of data. In this case, it'll be another 3 rows, and you're going to do it all again. So in order, again, to simulate this work, I'm going to have these things print out on the screen. So we're going to see print into the screen, pre-processing, more pre-processing, even more. We're going to see the actual data, 3 rows of it, and then we'll see the word post-processing, and it'll start all over. And it'll do it about 4 times. So let's see what happens. Let me scroll back up to the top. We see we did all that pre-processing. I have 3 rows of data, and then I have my post-processing, and I can go and get my next batch of data. Normally, people don't look at a single row or 3 rows at a time, but you'll look at, 1,000 rows, however much your memory can handle. But very convenient if you're looking at large data sets and you have a limited amount of RAM. All right. So you're reading in data, and your data that comes in is in some crappy format. The folks that gave it to you kind of using their style of formatting, and it doesn't match your needs. You can create a series of functions that will parse through the data you read in, change it, and then store the new version in your data frame. So I'm going to again read in from the same log file. It's 10 rows of data, giving it all the same columns as we had before, but I'm going to use converters. You can feed a dictionary into the converters argument, and the dictionary will say, for the email column, use the dsplitter function. For the date time, use the date only function. You can define your own functions if you want. You can use built-in functions from Python. I chose to create 2 very simple functions. The first one is dsplitter. It takes an email address and it splits off the domain. So I look at the address, I split wherever there's the @ sign, and when you do a split command, it creates a list of items. I'm going to break that list into 2 parts. I'll assign the first element from the list to user ID. The second element of the list will go to domain. And then I'm going to ask my function to just return those 2 things as a tuple. So I'm actually going to store a tuple in my data frame. For the date only function, I'm going to give it a date timestamp. If we recall, and I'll scroll up here, the date timestamps that we get are in standard international format. You have the year, the month, the day, separated by hyphens. You have a T, and then you have the timestamp, which is in hours, minutes, seconds. Well, in this case, I only really care about the date. I don't need the granularity of time, so I only want to separate off everything that's to the left of the T. So I say, take the date time, split it wherever the T is, and then I tell it, give me just the 0th item, which is the date, and return that. So when the converters run, it'll grab each of these columns, it'll run the converter, and it'll replace whatever content was in the column with the output of the converter. And we'll see how that works. So we look at data now, and sure enough, my date time is nothing but dates. Amen. And my email addresses are no longer email addresses. They are tuples with a user ID and a domain. All right. All right. The next item I mentioned, when you read in your data, we've told it you can skip rows, but we can also tell it which columns to use. Maybe I don't care about the latitude and longitude. Maybe I don't care about the date time. Maybe I just care about who sent an email and what IP addresses it came from. So you can tell it use particular columns with the use calls argument. You give it a list of just the column names. Run that, and we get data. Next. We're going to change gears. We're going to start talking about SQLite. Just about all the things that we talked about in terms of CSVs apply to reading in SQLite data. SQLite databases contain essentially tables, so you can read in from a particular table. In this case, I've got a SQLite database that exists on my laptop. It's called logfile.sql. It's basically got the exact same style of data that we've seen throughout. I think there's about 1,000 records. I can't remember. I start off by saying import SQLite 3. I then ask SQLite to connect to my database. This class is not a class on how to use SQL. We're going to presume that generally the folks in the audience understand how to use SQL. I tell it, the location in the file system of my file. It's a couple parent directories up. I create a connection object using con, and then I tell it, use your con cursor to point to particular places in the database, and then we'll move on from there. So once the connection is established, I'm talking to the database. I can then tell Python to read SQL. And you use typical straight up SQL queries, just like you would use in any SQL database. In this case, my query uses the SQL term select. I use the asterisks to say get all records, and I tell it select these records from the superheroes table. And I tell pandas which connection to use, because maybe I'm connected to more than one database. So I tell it use the con connection that I had created and create a data frame for me. So let's see what we get. TF, we see that it's 1,000 rows. The data is read in just the way we want. The database itself has column names. So when pandas reads in from that database, it grabs all the right column names. You don't have to name the columns. Doesn't mean you can't change them if you wanted to. That's a trivial exercise to change the column names to something you might be more familiar with. But you don't have to read in all the data. You can actually do, just like any SQL query, you can do selection of the data. In this command, I'm telling it select the date time, the email, the latitude and longitude columns from the superheroes table, but only where the name in the name column looks like Wayne, for Bruce Wayne. A couple things to note. Because this string stretches over 2 lines, I used triple quotes. That allows you to make a multi-line string in Python. Even though this is a SQL query, it is a string in Python, so all the string-related rules apply. The brackets, that's SQL. It's basically its way of kind of wildcarding. You can have wildcard characters in front of or after the word Wayne. And let's run that and see what we get. And also a couple things to note. Again, this is SQL as opposed to Python per se. But even though I'm only getting 4 columns, my checks, my conditionals, do not have to be related to those 4 columns. I'm getting date, time, email, lat, and longs, but I'm looking in the name column to kind of choose which names to collect. Hit enter. Let's look at the results. We see that we've got only the 4 columns I asked for, and all of them happen to be about a guy named Bruce Wayne. All right, next, in this case, again, kind of a lot of the standard pandas, data frame types of arguments apply. If I wanted the date time column to be my index, I use that command we saw earlier, index_call. And I run this guy, look at df2, and we see that now it's only 3 columns of data, and the date time has been relegated to being an index. And take a real quick look at the read SQL. You can tell it the index column to choose if you want. You can tell it to parse dates appropriately. You can do chunk sizes if you need to. You can set the columns you care about. If float values are coming in, you can coerce those to be a particular type of value. It is quite useful to dive into the help files. CSV is most popular, I'd say, in most cases. A lot of the things you can do in the CSV library will apply to other forms of the read commands. And we only touch the surface. Just for kicks, let's go back and look at read CSV again. A couple things to note. They give you all the arguments up front. They give you all the default values. Many of them are set to none or set to false. And then they very carefully try and walk you through each and every item. What is the separator? What is the default expected to be? Why would you use it? And when would you use it? They do have characteristics, like you can set it to read the data in, and you can tell it that you're in a low memory situation. There is a low memory argument. You can kind of do that manually with chunk size, but you can also tell it, up front to be careful with your memory, etc. If you have numbers that are supposed to be representative of thousands and you are in the UK, you can tell it which separator you use for large numbers that are more than 1,000, whether it be separators of period or comma. If you're looking at international dates where the date or the day might be first, you can tell it to do that. So lots of good flexibility here. All right. And I think that is the end of, nope. All right. The last thing we'll look at is, well, how do you get this data back out, right? How do you write it back out to a file? If you have a data frame, you can tell that data frame to be exported out using the .to command. In this case, I'm going to create a CSV. It's going to be called classout.csv. I'm going to tell it to read the data from the data frame 2 that we'd made a couple minutes ago. Tell it I only want 4 columns, the email, lat, long, and the name, in that order. I'm going to tell them that I want to have a header row. So I set header equal to true. And I tell it that I want my separator to be the pipe. And if I run that command, I should be able to look in my file. We see I have a file called classout. And if I ask to see what's in it using the more command, we'll see that it comes out. It's got X number of rows. They're all separated by pipes. Okay. Again, instead of using PD dot, you actually have to start from the data frame. And we see that there's 20 different some odd, or it's 17 different ways. No, I can't count today. 21 different ways to write out your data. You could write it to the clipboard if you wanted to have it pastable someplace else. You can write it to CSV like we just did, JSON. If you want to use LaTeX to produce some sort of document, you can write it out to LaTeX as well. Wide variety of cool options. If you want to dump it out as just a long string and have somebody else parse it, that's available too. So let's go look at CSV real quick and see what types of things we have available to us. So you see there's probably about 20 different types of arguments. Should NA values be represented as something in your output? What columns do you want to use? Do you want to have an index, yes or no? Should your lines be terminated with the line terminator that's used by Mac or used by Windows? Do your dates have some sort of format? Are you going to use some sort of quoting to quote your strings? Do you want to use an escape character? Should decimals be demarcated with commas or periods, etc.? So lots of options. And with that, so that's all we got today for data frames and reading data in, spitting data out. Do you guys have any questions? I did bring a puzzle to play with.
Any general guidelines on memory management? Say your SQL database is ingest and your laptop's working. Short of pushing it to the cloud.
Memory management.
What specifically are you trying to?
Yeah.
Well,
so the question in the room is, how do you handle memory management? Say you've got a big file and your laptop is small.
so example is like in the core world, there's like type databases so that it will pull in just enough information with the memory and then right after this. That's a good thing. So IO would be a little slower, but you're still able to still be able to process the
All you're doing is processing chunks.
Yeah.
So you can do the same thing with this, right? We need a chunk.
Okay.
Process it.
But you can run, you need to manually do that. I mean, let's say it's like a million rows. You have to break it down yourself into 100,000 rows at a time. Or
All right, so let's go take a look at this. So some of the conversation that's been happening in the room for those who are out there in Ethernet land, talking about ways that different programming languages might handle input and output. How do they do I/O in terms of controlling memory? So I'm looking here on the screen, and I'm trying to find The
Yeah, iterating
What-
files chunk by chunk.
they've got chunk size, but they also have somewhere in here, if I remember right, an item called low memory.
Set to true by default. It's okay.
I can't see it. I'm missing it. There it is. Low memory equals true. All right, so let's go look and see what that means, right? So we're going to scroll down through all these things and see what they have to say about this topic. And if I go past it, let me know. Did I go past this thing? Or is it the one item that they don't spell out in English? Low mem. Patterns not found. Gotcha. We found a bug. They don't describe what they mean by low mem. Yep. So I was actually taking a class the other day, and then the teacher specifically called out, they have this low memory option. You should use that. Memory option, pandas. So we're going to do a little bit of Google foo, and we're going to try and figure this thing out, right? Pandas, read CSV, low memory, and D-type options. Who knows what we're going to get? Let's see if we get anything fun. Interesting. The low memory, according to someone, some expert on Stack Overflow, the low memory option is not properly deprecated, but it should be. Since it does not actually do anything differently, there is a source that we could click on if we wanted to, but that's a lot of work. We could always go to the documentation, see if they have anything to say about low memory. Because now you got me curious. Low memory. Low memory only shows up on this page one time, and it's the same file that we were looking at on the screen a minute ago.
That's probably a red herring, if it's been deprecated anyway.
Yeah.
I think really what you're interested in is chunk size.
Yep.
Just making sure that you write code in a way that it can be processed in chunks. Right, so rather than reading the whole thing in, you're reading it with some kind of iterator or something, and it'll read it in chunks, and it'll provide iteration for you to process chunks.
Without spending the entire time trying to Google this answer. The unsatisfying answer is you might have to manage chunk size manually. You would hope that there was some sort of way to kind of do that, but it won't necessarily. I mean, that involves a lot of like system knowledge, right? Pandas would have to check to see what your memory is and how big the system or how big the file is going to be. Is it reading it in? And what are your limits on comfortability of how much memory should be used at any given time?
Yes and no.
That gets clustered.
If you're doing something that's simply iterating over rows of data, then yeah, you're gonna have to make a semi-smart decision of what the chunk size is because it's gonna read the database in chunks of that size. Right? So maybe the chunk size is 1,000 rows, or maybe it's 10. Or if you're calling across the internet, you want to do bigger chunks. If you're local, it probably doesn't matter as much, etc. But if all that's happening is the data is coming in, is it's being passed, you're enumerating it and then doing something.
Got some cool conversation happening over here.
Something too big, but realistically, you probably want something that's maybe a few megabytes like that. If you're reading from a file, chunk size is less of an ordeal because Python is already doing a lot of So really, ideally, your chunk size is going to be a function of the characteristics of what you're doing, not characteristics of the function processes it. If that makes sense. It's processing it a row at a time. So it doesn't matter what your chunk size is from that perspective. Right? So if your database is really good at combining the make right, yeah, sure, right chunk size. You know, if you're on a network that has a lot of noise, you probably want smaller chunks just to avoid collisions or whatever. But that's nothing about processing. That's much more about the characteristics of the source. Right. Yeah. Once you're doing some kind of transformation, you kind of need unless you go a full MapReduce route, and Python does do MapReduce, then you read in chunks instead of your mappers and reducers. That's a whole different question, right? A whole different discussion.
And so in a case like this, say you're reading in data, right? And you don't need all of the data. Maybe you just need particular columns. You could read in a large chunk, you reduce it down to just columns you want, and then when you read in the next chunk, you know, it eliminates all that overhead, right? And you can pull in chunk at a time. You can also do, as we saw, if you have a function that's going to convert your data from one format to another, maybe you're looking for a large string of text and you're only looking for those strings of text that have particular characteristics about them, and any other row that doesn't have those characteristics you just don't care about. So you can use the converter function and a dictionary to feed functions in to basically parse or evaluate each of your rows, convert them and stuff. So there's a variety of ways to kind of filter out what you don't want without actually cluttering up too much of your memory. But this topic is really cool. I'm glad you asked the question, because now you got my head spinning trying to figure out, all right, so how would I answer some of these questions in the future? This is awesome.
So Python is kind of nice about it. It allows an interface for, like when you say like, open up this file, it returns a file-like object. And by default, like, let's say that you iterate over it. It's just going to like iterate over each line. Now, I don't know if it loads the whole thing in memory, but what you can potentially do is
More awesome conversation happening over here. Sorry.
So like you can create like a for loop and say like for, you know, however many, and just say like, you know, this file dot read this many bytes until like you get some sort of exception where I can't read from it anymore, and then exit out of the loop. Okay. But that's something that you can handle yourself.
Yeah, to read in the chunk, transform the data, and write it.
Yeah.
Cool. Any other questions? All right.
The corollary to that, or the tangential to that, is sometime in a date range as yet to be determined. I'm going to be talking about comprehensions, and then shortly after that, I'm probably be talking about reducing something, like how you deal with iterating over very large data sets, as in very large, like terabyte size or petabyte size, where suddenly do it. So we'll be talking actually about starting to address on the edges some of those questions. And that's especially interesting when you say, well, what if I want to split my processing up across multiple machines? Which is what MapReduce really has made a name for itself in. But also, I just have too much data to have in memory at a time. So how do I think about my algorithm in such a way that I can break it up into chunks, especially with simple aggregation?
Still more awesome conversation.
That's just read in chunks. Add one for every row. When you want to do, like, say, find correlations between things, where suddenly you break it into pieces, and each of those pieces has meaning, but it doesn't have meaning without other information that was in the different piece. How do you do that? So that's the whole related topic, because as the data sets get bigger, you really have to if iteration by itself is enough, then just jump in.
All right. So I had a thought for the next half hour or so. We can kind of go through a puzzle from Check.io. The reason I picked this puzzle is because I was looking at some of the other ways that people solved it. I found 3 neat and interesting ways they solved it, or the way they approached it, and I thought we could learn some interesting things from how it was done. So let me pull up the puzzle itself. It's fairly straightforward. You have 3 items, and you want to solve for the area of each of these items. You have a circle, you have a square, and you have a triangle. You need to create essentially an algorithm that if you tell it one value, it will assume that it is a circle and it will return the area of the circle. If you give it 2 values, it'll assume that you are asking about a rectangle and it'll give you the area of the rectangle. And if you give it 3 values, it will presume that you want to know the area of a triangle where each value is the length of a side of the triangle. So your function kind of has to determine how many arguments did you give it. Once it determines how many arguments you gave it, it's got to kind of work with that and choose the right algorithm to solve for the area. In this case, at the bottom, we see that they gave us like 5 sample tests. The first one was a circle with an area of, or a radius of 3. Is it a radius? It's a diameter, sorry. It's a diameter of 3. You got to solve for the area. The next one was a square with sides of 2 by 2. The next one is a rectangle of sides 2 by 3, and then the triangle. All right. So we'll go ahead and we'll try and solve this. I think I've got my answer already in there. Let's get rid of all that cruft, I think. And let's get rid of my original answer and we'll come up with some of our own. All right. So any ideas on, if we were to write this out in English, what steps we would take? We can kind of comment our code a little bit and figure out what code we want to write. What would be some of the steps we would do? Any thoughts? Okay, so we might want to figure out how many arguments we have. So I'll just put that as a comment. Determine the number of args. That's all right. Then what might we do?
And you're essentially switching on that. Python doesn't have switch, so it's going to be the if-else chain.
Okay. So maybe, decide which algorithm to use. Maybe down near the bottom somewhere, we want to return the area. Maybe we'll end up having 3 different algorithms, right? Maybe the circle algorithm, square algorithm, and the triangle algorithm. Do we have a sense of how we might determine how many arguments we have? What tool could we use to do that? To figure out how many arguments we got. All right. So we could do something like this. Num equals something like len, and we give it args. It should be args. So a couple things to note for those who haven't used functions in this way. If you notice that I've got up there in the function definition, let me blow this up. I apologize. This is smaller than I pictured. Okay. Whoa, make that go away. All right, too big now. All right, so when you have a function and you want to provide it an unknown number of arguments, you can tell it to expect an unknown number of arguments by putting an asterisk in front of the argument name. In this case, I'm going to tell it you're going to get args, and we don't know how many you're going to get. Inside the function, when I refer to args, I don't have to put the the asterisks. And in this case, when I use the length function, if you've never seen it before, it will count the items in a iterable. So if I have any sort of sequence, a list, a tuple, a string, it will count how many elements are in those. So here it'll say how many elements did you give me in args. It spits it out as num. How do we decide which algorithm to use? Once we know that it's got like one argument or two arguments. Jeff mentioned, well, there's no switch selector like there are in some languages, so we could use something like an if statement, and maybe an elif statement, and maybe an else statement. So we would have, some characteristic that we have to check for. All right. So we'll say if num equals 1. Yeah, good call. Those who haven't seen that or didn't hear that, when you're assigning a value, use a single equal sign. If you are testing for equality, use a double equal sign. All right. So we might want to run the circle algorithm. Who knows how you figure out the area of a circle? Pi times radius squared? Excellent. So the fourth dimension says that you want to take pi and multiply it by the radius squared. But in our case, the radius is half the diameter. We know they're going to give us a diameter, so we're going to have to solve for that. All right. Okay. Yeah. I'm going to go up here. I'm going to import math. And we will say our radius is equal to args 0 and divided by 2. Paul, somebody here is keeping me honest. It's all good. All right, so the radius is the argument divided by 2. And we can return math.pi times the radius to the second power. Do we have to do anything funny with parentheses or anything? Or will this math work the way we want? All right. So the peanut gallery says that it'll work just fine, but let's test it. Import math. Right? Or something. Import something. And let's see. Let's set the radius equal to equals 2. Math.pi times radius to the second power gives me 12. So 3.14 times 4. That seems to work out quite right. Let's see what this one looks like. 3.14 times. Wow, I didn't want to do that. I want my radius to be something different. Let's make my radius 3. Make that to the second power. 3 to the second power is 9. 9 times 3.4. So the math seems to work out just fine. If you guys remember from your math days, Python follows the standard conventional order. PEMDAS, parentheses, exponentiation, multiplication, division, addition, and subtraction. So it will prioritize exponentiation before it does multiplication. So that's why this works out fine. If you ever feel like, man, I'm just not sure, I want to make sure, Python does not care if you put brackets around something to make sure that it does that element first. It's all good. And notice the answer remains unchanged. All right. So we know that the formula should work. All right. So if the number of arguments is 2 and we have to solve for the area of a square, what do we do there? We say elif the length, or elif num equals 2. Somebody in the peanut gallery says, Chalmer, we're going to remind you again, it's equals. And all right.
Is there a linter for Python?
Yep, PyLinter.
A linter, okay. I should probably run that on my code.
So there was a question here. Somebody said, is there a linter for Python? And for those who don't know, linter essentially evaluates your syntax and tries to help you figure out whether or not your syntax follows all the conventional rules and tries to help you find bugs before you commit to your sins.
Or just a style guide too. So, yeah, so there's actually a linter called PEP8, which is literally just PEP8 advisor code.
All right. There's also other linters. There's one called PEP8, which will kind of make your code more stylized. All right. So here's a thing. If we want to know the height of the square and the width of the square, all right. So an interesting thing, if we get in two arguments, they're going to come in essentially as a list or as a tuple, and we can break them out and say, give me the first item of the args and give me the second item of the args, and store the first item as the height and the second item as the width. This is called tuple unpacking or unpacking in general. And my formula is just height times width. All right, there we go. And lastly, the only other option is if we have 3 arguments. So we'll put that as else. We don't have to test because it's the only other option. And we can say side A, side B, and side C is equal to args. And it will unpack. And now we have to figure out the formula for a triangle. And there's this really smart guy. He created a formula for a triangle given the sides. There we go. It's Heron's formula. So let's open that up, see what we get. So Heron's formula is to take the square root of the perimeter times the perimeter minus A times the perimeter minus B times the perimeter minus C. And it's not quite the perimeter, it's half the perimeter. So calculate for half the perimeter, and then you put that into this formula. All right. So we'll do that. We'll create this formula. We're going to solve for P equals A plus B plus C. And we'll divide that by 2. All right. And then we'll return the square root, the math square root. And P times parentheses P minus A times P minus B times P minus C. And we close that up, making sure that all my math looks right. And it looks like it should work. Lord willing. I think everything is good. Now, I will say up front, this is not necessarily the most efficient code. There's ways to tighten it up, make it shorter, probably make it cleaner, and we'll look at a couple of those in just a second. All righty. So all right, so we got all these unit tests. It's going to feed in a bunch of things, and we'll run it, and we'll see if it works. Run and check. And we wait, we pray, and it went through 12 tests, and it solved all of them. All right. I'm going to shrink the size of the font a little bit so we can see some of the tests better. So, for example, huh? No.
Command and either minus or plus. You don't even need the shift. Just command minus or command equals. And command 0 to 100%.
Sweet. You are the man. You've been teaching before. All right. So if we feed it, for example, a value of 1, it calculated that this thing was 0.78. And it's kind of neat sometimes to go and look at the different tests. Like they give you a square that's 1,000 by 1,000. They give you a triangle that's 1, 1, 1, a triangle that's 10, 2, and 9, etc. Right? But we passed them all. All right. So let's look at a couple of different ways to do this that might be a little more efficient, might save you a little bit of typing. One of the ones that I liked was the guy actually wrote individual functions for each type of algorithm. And then he used a dictionary to choose to call each of those. And I'll show you how that works. All right.
That would work really well with pandas, which you indicated you're
Interested in.
interested in. Yes.
All right. So I'm going to start off by putting the import statement outside of the function. I'm going to say from math import pi and square root. That'll save me some typing later. I don't have to type math dot all the time. So that'll make that easier. Okay. And we're going to make 3 small functions. First function will be circle. And we're going to feed it a diameter. Right. And inside, we're just going to simply return the diameter divided by 2 times 2 times. All right. Again, Python is going to use the standard order that math happens. It'll do the exponentiation first, and then it'll multiply the result by pi. Our next function is square, and we will get width and height. Awesome. Peanut gallery's in fine form tonight.
Well, because it's not only square.
All right. We will change the name. It is not only squares. Rectangle. Sweet. And def. The last one is triangle. And we're going to feed it A, B, and C. And say S equals. That's right. I should not have deleted this. That was a horrible thought on my part.
Z a bunch of times, copy. Shift Z a bunch of times, paste. I use that one a lot.
Yes. All right. And we're going to return the exact same formula we had before. Square root p times p minus a, p minus b, p minus c, and a close. There we go. All righty. Now here's where the fun part comes in. This is why I wanted to show you this one. Area function, and we create a dictionary. 1 circle, 2 rectangle, 3 triangle. All right, so let's walk through what just happened there on that line. Thank you. All right. So the very first thing we do is we create a dictionary. And the dictionary's got 3 keys to it. First key is 1, the second key is 2, and the third key is 3. Each key has a value that's associated with it. And Python considers any object you make to be a first-class object. And you can actually dump functions into dictionaries, not just strings, not just numbers. You can actually dump functions. So I am putting a function as my value for the first part of my dictionary. I'm dumping another function as my value here. The dictionary as a whole is an object in Python. And if I want to tell Python to look at a particular item in the dictionary, I can use the standard bracket indexing notation. So I could say something like, my dict. And if I wanted to look at, item 1, I would use this indexing capability. Well, I've got a dictionary. We chose not to give it a name, but I can still index across it. And the index that I use is the length of arguments. So if I have 3 arguments, my index becomes a 3. And it will tell the dictionary to look at 3 and return out of the dictionary this function. And it will store that function with a brand new name called area function. So easy peasy, in a single line of code, I can basically choose which of the 3 functions I want to run. And then we say return area function, and I give it however many args we had. So the first line chooses the function to run, gives it a brand new name temporarily, and we feed it the right number of arguments, whether it be 1, 2, or 3. And depending on what my dictionary returned, it will return the right function, and it'll feed it the right number of values, and everything works. And if I hit run and check, hopefully everything flies. Line 9, some sort of fail. I left off my colon. Yep. P is not defined. Let's go figure that out. I failed to define P. I could have sworn we wrote that in there. Equals A plus B plus C divided by 2, right? Okay. Try it again. Fingers crossed. Sweet. Okay. So let's look at the code real quick. 3 functions. We can essentially create almost a switch-like functionality to tell it which one to use. We haven't used a single if else, or else statement. I use this ability to call functions kind of on the fly regularly at some of my work. And let's look at one last way to do this. Let me see if I have this text saved anywhere so I don't have to type it all out. What did I do? Oh no. There we go. All right. This is the one that uses decorators. Nice. All right. So I'm not going to type it out. Too lazy to do that. All right. So we start off, we import math. We create areas equals list. It's an empty list. And this guy created a whole slew of random functions and such. So we'll kind of walk through them, and we'll try and decipher what's going on as we go. He created a function that on the fly will take any value x and divide it by 2. So if you have a diameter, it creates a radius. If you have a perimeter, it can create a half perimeter. So here, he created a function called circle. You feed it a diameter. He uses his little half function that he made to create a radius. And then he uses the same formula we had before, radius to the 2nd power times math. He created another function to do the rectangle. He created the same function to do the triangle. He uses the same math. He called it S instead of P, but it's basically the same thing. He calculates half the perimeter using his half function. Again, that seems like more work than it was worth, but hey.
This is terrible code.
Yes, right?
This is really bad.
But the areas of n pieces.
Yes, all right. So he's got this list, and it's called areas. And he chose to use a decorator called areas.append. And what will happen is, as it goes through this process, and it runs any of these given circles or any of these given functions, the list called areas has an append function, and it will run that, and it will take the result of each of the functions, and it will automatically append it to the list areas for you. And then once you've created areas, once you created this list, it will go through and it will look at each area that you've created, and it will try and solve for the area based on the number of arguments you provide. And if any of those functions fail because you give it three arguments, you give it 2 arguments, and it's expecting more, it will just give you a type error, and it will continue and try and run the next function. I'm not going to go into all the details of explaining decorators, but a friend of mine and I were talking about it, and I told him that I'd come across this example. You can look up decorators. They're actually kind of neat. They allow you to essentially wrap a function inside of another function without using a lot of syntax and a lot of typing. And it takes the result of the inner function and runs it through the outer function. So in this case,
very handy when you're doing, like, for example, security checks on something,
Mhm.
right? Run this function if the user passes a security check. Otherwise, don't run the function. And then your security check would be written in one place. You don't have to have all your ifs everywhere. You just decorator on it, and you know that outer function is going to be running every time before you run. So like in writing something for distribution on the web or whatever, you're simply, for example, put a user authentication check on every method that should have it with a simple, 1 line of code you copy and paste it.
all right.
Actually, probably the best example I've seen of decorators is the Flask library.
Mhm.
So it's a framework that lets you write web apps, but it uses like the decorator syntax where you say like
Cool conversations happening in here. Hang on.
to my URL, and then right below you define the function that will return whatever you should get when you hit that particular URL. Because like decorators are inherently kind of complicated, but like when you have like a complicated construct, like you generally want to use that complicated construct to make something that's hard more simple, and that's a really good use case.
But at Django, this gives, for example, Django REST framework. Well, actually, Django CRF checks are on by default in Django. If you want to disable them for a particular route, you put the @CRF exempt decorator on that route, and that route alone will not have CSRF checks, even though all the others do. So, and same thing with permission classes. Right? Users should be able to access this if you don't have to have, another dev can look at it very quickly, say, oh, okay, this is a rule. The decorator tells me exactly what the example is.
That example up there, I mean,
Can we pause this conversation for 2 shakes? Let me speak to the mic so the folks in the real world can hear what you guys have talked about, and then we'll continue. So a couple things that have been discussed here in meat space, for those of you who are in Ethernet land, talked about reasons and places you might use a decorator. I'll cover that in 2 shakes, but I want to cover a little bit more about what a decorator means. So in this case, on line 3, they created an object, and it's an empty list. It's called areas. Every list has a function that's built into it called append, and it allows you to add some new item to the list. The hard way, the thing that requires lots more typing and stuff and can make things very complicated, especially if you have multiple levels of nested lists or nested functions, would be to do something like this. Type areas.append, and then you would include your function inside of that. You might include the function circle, or you might include the function rectangle. And you would have to nest all the details. You'd have to put diameter in here, etc. If you have multiple levels of nesting, things can get very complicated. And it makes it, in some cases, more difficult for you to read the code. So they came up with this idea of decorators. And they said, instead of having to type all of this and nest everything, let's just put a decorator in front of a function where we want that decorator to be used. So lines 8 and 9, for example, where we're appending the circle function to the areas object, is identical to what's happening on line 30. But it's a little cleaner. It looks a little neater. You can store the areas function elsewhere if you need to. people can focus a little more on what is the circle function going to do. And in your code itself, if later on you wanted to call the circle function to do something, you can simply call it and say diameter. And automatically, Python will immediately dump the contents of the circle function into the area's append function for you, because you appended or you put the decorator in front of the function name. How is this useful? A couple of examples were given here in the classroom, right? Say you're doing security authorization checks. You have a security function that will do certain checks. You have something else that wants to happen, but it should only happen if the security function passes. You can use a decorator in that case. A simple one line of code can, in several places in your script, can make sure that the security checks happen at all the right places. Stefan mentioned a library out there called Flask, and Flask is a web development platform. Helps you build web apps, and it checks for a variety of things. It could be authorization, it could be user validation of the inputs that are coming in, the outputs, it could be a formatting type of decorator. There's a variety of them. Stefan's more versed in Flask than I am. So in a nutshell, you can make your code a little more readable. You can ensure that when a function is called, additional steps are taken before your function is run. And security is a big player in that kind of thing. But formatting, data manipulation, transformation of data, data wrangling, those are all good cases where a decorator could be really useful. But today's not the day we're going to talk all the details of decorators. I just want people to be aware, and Stefan and I talked about it, and I thought it would be cool to show it. So what the heck?
Decorators are cool, but like that's what I was trying to say, is that because like they are things that are weird to wrap your head around, like I highly recommend like only trying to use that stuff where it's useful. Like in this case, like there's a couple things that I don't like specifically like the for loop where he like tries to do
That's expensive.
That's yeah, and like it's buggy. Like I definitely want to like caution people, because I run into this a lot where like I'll try and implement my logic by just trying to catch as many exceptions as I can, where like it's totally avoidable, which is bad because it is expensive, and it also like just leads to buggy code. Like there's it's a cool example, but like please don't ever do like something like that.
So a couple comments that were made here about the code that's in here. Doing the error checking and all those things, the try, except, that's what we call expensive. It requires a significant amount of processing that may not be necessary. There may be cases where you're not sure what you're going to get. In this case, because it was a very simple program and we knew exactly what kind of checks were going to be done, we knew we were going to get 1, 2, or 3 arguments. We didn't have to like really test to see if there was too many. Plus, in this case, it creates a list that has 3 separate functions, and it tries to run each and every function. And if one of the function fails, it will then move to the next one. Using kind of the dictionary option we tried before, or the if else, we simply look, does it have 1 argument? If it does, do this thing and skip the rest, instead of trying to like brute force our way through them. So lots of do not do's in this code, but also some fun, cool stuff too. All right.
Actually, this is kind of a cool example where
We're about to run out of time. They're going to kick us out.
sorry. But
Go ahead.
This is actually, I think, a pretty good use case for object-oriented programming, where you can have, like, say, a class shape that will have an area method, and then you can, inherit from that. Depending on the, you can have a class for like circle and one for square, and like, if you want to get like more technical, you can use Python has abstract base classes, where you can say like, this is my base class, and these are basically the attributes and the methods that I expect anything to inherit from this to have. And then if you inherit from that and it doesn't do, like if it doesn't have those things, it fails. And what that does is it creates basically a contract in your code that anytime that you see like this particular thing, like it's going to adhere to that interface. They use it. That's actually kind of a cool thing in Python if you ever want to look at abstract base classes. There's an article that we have in Slack on in the Python channel about it actually.
Cool. So Stefan was talking a little bit about the idea of if you wanted to get kind of crazy with this. You could actually set up classes for each of these items, and you can have a base class called shape. And circle or triangle or square would inherit from all of those things. So with that, we're going to close up. We appreciate everybody listening. I'm going to try and get the YouTube video cleaned up a little bit, and we'll get it like posted for Reels here shortly. Thank you guys for coming, and we'll see you 2 weeks from today. Oh, one cool thing. Stefan and I are in discussions right now with a gentleman from Google. He's coming out to the island to be here around, I think, the 31st of May. And he's really interested in doing a talk on Docker, Kubernetes, and Python. So if anybody's interested in those kind of technologies, we're going to try and we'll get the word out to folks. We're going to try and find a place. We'll try and see if we can get a nice group here to welcome this gentleman from Google. So with that, have a good night. Thank you. And like I said, we'd like to get so we'll start advertising this thing out, get to know people, share it out with folks. I mean, we could try here. We haven't talked to them yet.
Contact Shania at
You got to squeeze the handle.
Oh, okay, yeah.
The space they're in right now is like a bigger meeting space area on a Saturday or Sunday. They should be really nice. It shouldn't be a problem. I think. Well, maybe, but yeah, just contact. They have an info email.